Okay, let's get started. This one, you haven't done it yet, right?
Where did we stop? Yeah.
Okay. I can't even remember what was the last lesson that we have done it.
We did this one.
Yeah, okay. What about this one?
No, we stopped here, I think.
Okay. So I think this one we discussed it before, so it was the first time to hear about it. But this one sounds like, you know, just a little bit. Um, wait. Okay, what's there? Okay. So every single time, let me show you. This one, I need to remind you that we need to do something. So the point is, um, we have four. Oh, oh. Okay. So let me remind you that we have four quadrants, right?
Mm-hmm.
All trigono. This one sounds like the first quadrant. This one second quadrant, third quadrant, the last quadrant, right? So let me
Yeah.
write A. You know, A stands for all trigonometric function in the first quadrant are positive. You know, even if you try to find out, I mean, sine, cosine, tan, or even the reciprocal, still positive in the first quadrant, right? But what about the
Yeah.
second quadrant? The second quadrant, we have only, I mean, a couple things are positive. The sine, let me write it. It stands for sine and reciprocal. That's supposed to be cosecant, right? Um, and there we have the oh wait, hold on, my bad. This one tan and cotan are positive in the third quad. In the fourth quad have cosine and secant, right?
Mm-hmm.
So the point is, let me remind you that we have something that sounds like on this one. It looks like the key. I told you that we always use 180 and 360, right? So if you want to go there, I mean to this one. So I mean, no need to do anything because all of them in the first quadrant are positive, which makes sense. This one it looks like obvious, right? But what
Yeah.
if I'm trying to find out, for example, I'm trying to find out why sine 120. You know, 120 is this one sounds like obtuse angle, which makes sense. This one sounds like a related angle. I think it's this one we discussed it before the last meeting, which makes sense. I need to break it down in two parts, couple parts, right? But remember, where can I find 120? So 120, it lies in the second quadrant, right? It lies there, which makes sense if it lies there. So it's going to be 180 minus theta, or this one, it's going to be 180 plus theta, right?
Yeah.
And if this one, it's going to be 360 minus theta, which makes sense if you want to find out why sine 120, 120. So the point is, sine 120 is this one, I could write it just like sine 180 minus 60, right?
Mm-hmm.
Because if you try to subtract them from each other, you would return back to sine 120, right? And don't worry, it gives you that sine. Let me write it. Sine 60 equals to root 3 over 2, which makes sense every single time we get sine 180. This one, it must be canceled. No need to write it. But the point is, you need to investigate how either this one is positive or negative, because this one lies in the second quadrant. I was trying to define it, and I told you that in the second quadrant, we have only sine, right? Which makes sense. This one is positive. So sine 60, so it's going to be root 3 over 2. You get it?
Yeah.
But what if you got something else? For example,
Oh.
if I told you sine 45, for example, which is going to be 1 over root 2, and all of a sudden I asked you that we got sine 225. Now, firstly, we need to determine where can I find it in which quadrant. You know, let me try to return back to this one. So what do you think?
Uh, Last one.
Oh, oh, this one from 270 to 360. So it makes sense that
Middle one. Middle.
not this one. You meant third one, right?
Yeah.
Yeah. Okay. So
Yeah.
um, this one could be written just like 180 plus something, right?
Mhm.
Look at this one. So it's going to be 180. So instead of writing 225, this one could be, it must be replaced with 180 plus 45, right?
Yeah.
You could check, because 180 plus 45 is going to be the same thing of 225. But basically, before doing anything, you have to remind yourself whether this one is positive or negative. So sign in the third quadrant, well, this one applies in the third quadrant, right? So do you think that sign in the third quadrant is positive or negative? What do you think? Look at this one.
Well, which one?
I mean the third
Negative.
quadrant, right? Negative, because the
Negative.
only trigonometric function, I mean there is a tan, or the reciprocal of it, cotan, but this one, it looks like this one is sine, right? So
Yeah.
makes sense. This one must be just, you could write it just like negative. This one I was trying to remind myself, so I wrote it as a coefficient. So negative sine 45, right?
Yep.
But the point is, this one we have to use it. Sine 45, this one could be replaced with 1 over root 2. So this one you could write it just like negative 1 over root 2. Did you get it?
Mhm.
Okay. I'm not quite sure. I mean, in the example, it was sine 330. You can do it by your own right now. So where can I find it? Sine 330.
360 to 0.
330. I didn't say it's 360. Yeah. What do you say?
Yeah, that quadrant.
Which one?
The 360 one.
Yeah, you meant 0, right?
Yeah.
Okay. So this one could be replaced with sine 360 minus 30, right? Because if you try to return, I mean, to subtract them from each other, 360 minus 30 would return back to sine 330. Exactly the same, which makes sense. Let me investigate whether this one is positive or negative. So we got sine 360 minus 30. So the only trigonometric function in the fourth quadrant is positive, is cosine, right? And this one is sine. So what should I do? I need to write negative, right?
Yeah.
Negative sine. This one, it's been canceled. So negative sine 30, right? And don't worry. This one's going to be, this one's been given sine 30 equals to 1 over 2 or 0.5. Not quite sure, but anyway. So it's going to be negative 0.5. You get it?
Yeah.
Do it again, I understand it.
Understand that.
Okay. So, can you do it by your own?
Yeah.
Unfortunately, I won't be able to write on the PDF. So, this one gives me. Okay, I'm going to use it because I need to write. Okay, so we got sine 30. This one, it sounds like it's been given the information, which equals to 0.5, right? And here we have sine 330. So how could I need to break it down 2 parts, right? So it's going to be sine
360 minus 30.
Yeah, right, exactly, perfect.
Negative 30, sin 30.
Do you think this one is positive or negative?
Negative.
Yeah, negative. Applies in the fourth quadrant. So it's going to be negative sine 30. And this one, it's been given sine 30. Sounds like 0.5, which makes sense. let me use it, negative 0.5. But I cannot understand it.
Understand it.
Okay. Let me write this one down. 5 c power negative 2 divided by c power 3 multiplied by c power 4, right?
Mhm.
You know, every single time we have a negative power, I have an issue with that. So I need to swipe their places. If you have a positive, no need to move it. But the point is, if you have a negative, right? So let me highlight it to remind myself this one. I need to push it down, right? So what I want to do, I need to keep 5. I don't have to push it down. So it's going to be 5 there. So see, it's a negative 2. C to the power of negative 2, right? But let me show you. This one's going to be c power 2, right? Multiplied by c
Yeah.
power 3 multiplied by c power 4, right? And this one, it's kind of the law of indices to make sense. I have the same base. I need to add up all powers together. So it's going to be 5 over c to the power of, yeah, I'm waiting for you. C to the power of,
All right. 9.
yeah, where did you get it?
2 plus 3 plus 5.
Yeah, right. So is this one clear for you?
Yeah.
I think it's obvious.
Yeah.
Okay. Look at this one. This one sounds like it's not complicated, honestly, but you need to understand how does it work. No, this one, it's kind of graphing the cosine, which makes sense. The cosine, it starts from 1, right?
Mhm.
Oh, let me show you. If we try to graph cosine, I mean the trigonometric function, cosine x, let me zoom in, starts from 1, right? So is this called, the range of it from 1 to negative 1, right?
Yep.
Okay. But if we try to make a comparison, this one starts from 2, not from 1, right? You get it? You get the difference? But let me try
Yeah.
to graph, the cosine. Let me do it. I think this one starts from 1, right? And here we have, 90, 180, no, 270, 360, right? So it looks like this one. But if we try to make a comparison between this one and this one, the range there, we have 1, right?
Yeah.
Not too perfect. Oh, anyway, so the range there is 1, right?
Mm-hmm.
1 to negative 1, as I told you. But the point is, this one, it sounds like 2, right?
Yeah.
So it means that B y equals to cosine x plus a. A, it sounds like degree, but B, this one, it's kind of, this one, it's shifting up only 1 unit because it was 1, but right now it goes into 2, which makes sense that B equals to 1, right? It's obvious.
Yeah.
Did you get it?
Yeah.
Okay. But right now it's time for, I need to know how many times, right?
Yep.
This one, I tried to push it to the right. So let me show you. So look at this one to this point, right? So how many times did I try to push it? Did you get what I mean? What I meant? Or you don't
Yeah.
understand it? Okay. So, but the point is, the graph, it looks that this one, it's been reflected, right?
Yeah.
In this case, it sounds like I'm trying to push it, but be there. How many times did I push? So let me count. I mean, 1, 2, 3. 4, or in this case, I need to write. It sounds like negative. I need to count how many times it's going to be negative 30. But do you know why? Do you know why did I try to use negative?
Yeah, because 360.
Yeah. Did you get it?
Yeah.
Okay. The other one. So the other one sounds like we have an inequality, but the point is, we get a fraction, we get a denominator. No, I have a couple of ways to do it, but for me, let me write down firstly. Minus 2 greater than 3x over 5, right? How could I do that? Do you have an idea?
Double.
Um, uh, I'm looking for LCM. No, the least common multiple. I'm looking for it. Do you know why the LCM? Because the point is, let me show you. If you get something like, if you have a really simple equation, it looks like x over 3 minus 1/3, which equals to 4/3. This one, I think you've noticed that all terms, it's been divided with, all terms have been divided with 3, right? Which makes sense. The first thing pops in mind that I have an idea. I'm trying to multiply the entire equation by 3 because I'm trying to get rid of 3, right? So the best thing for me, just try to multiply the entire equation by 3, which makes sense. This one's being canceled. So it's going to be x minus 1 equals to 4, right? I was trying to turn it from being ran into complicated form into simple form, right? So in this case, I need to add up 1 and add up 1, so x equals to 5, right? Sometimes I don't like to deal with fraction. I tend to turn it into a whole number or integer, right? So here we have the same thing exactly. I'm looking for which number should I multiply the entire inequality to turn it from being ran into fractional form into integer, right? So I need to get rid of 3 and 5 at the same time. So the LCM is going to be 15, right?
Mm-hmm.
So I need to multiply every single term by 15. And remember, whenever you have done something to the left-hand side, you have to do the same thing to the right-hand side because we are trying to keep it in balance, right? Which makes sense. In this case, I need to multiply this one by 15, this one by 15, and this one also by 15. So remember, let me remind you, I try to multiply this part by 15. 15 divided 3, what is 15 divided 3?
5.
You said 5?
5. Yeah.
Yeah, I wrote it there. This one's been multiplied with x plus 1. Remember, I wrote, I've ran a parentheses to remind you this one need to distribute 5 all over every single term inside it.
Wait, so you divide by 15, not multiply?
No, I try to multiply by 15 because I'm trying to get rid of 3 and 5 at the same time.
But you just divided.
Oh, wait, hold on. Look at this one. If I told you that we get, 1/3, right? And I told you that I need to get rid of 3. So you told me, for example, we need to multiply by 15, this one, right? So this one sounds like 15 multiplied by 1. So it's going to be 15 divided by 3, right? Because I multiply 15 times 1, it's going to be 15 divided by 3, so it's going to be 5. You get it? Is it clear for you?
Yeah.
Here we have the same thing, exactly. 15 divided by 3, it's going to be 5. I wrote it already. Minus 15 times 2. What is 15 times 2?
All right.
Yeah. I have to do the same thing. I need to multiply this one also. But remember, 15 divided 5 is going to be 3, right?
Yeah.
So what is 3 times 3?
9.
Okay. Oh, can you do it again?
No. Oh, wait, what?
Can you do it again?
Yeah.
So tell me. What should I do if you got something like this one?
Uh,
I was looking for the LCM, right?
yeah, look for the lowest common
Multiple.
factor. So, multiple, so, 15.
15, because both of them are prime, right? This is the reason why I did a big
Yeah.
15.
And then they multiply 15 by everything, so
In there, also 15 there, 15 there.
yeah, so
So
15 divided by 3 is 5.
let me write 5.
X plus 1
15 times 2,
minus 30.
yeah, greater than 15 divides 3, 5.
Yeah, 9x.
Yeah, perfect. But I haven't done it yet because we still need to distribute this part, right? Okay.
5x plus 5.
Minus 30 greater than 9, right?
Yeah.
So what should I do? So this one sounds like 5x. Let me write it. 5 minus 30. So this one's going to be negative 25, right?
Yeah.
Greater than 9x.
No.
Makes sense. No, I'm trying to combine the like terms together. So I need to subtract 5x from both sides, left-hand side and right-hand side. This one's being canceled. This one's negative 25. This one's 4x, right?
Yeah.
And then I need to divide by the coefficient, right? What was the coefficient?
X.
I mean 4.
4.
Right? And the other one also. So x less than negative 25 over 4.
Yeah.
Is that clear for you?
Yeah.
Do it again?
No, understand.
Okay. I think it's obvious. It's not hard.
Yeah.
But let me end up the meeting and try to rejoin from the same way. Okay?
Okay.